Yes, your eyes do not deceive you, we've now got mounts in the game. If you're new here, my name is Eidos and this here is my solo project, a 3D platformer RPG where everything you see is made by hand. This is the second of the few videos I'm doing during the summer that are a bit more technical than what I covered in my first 3 videos, but I'll try to do my best not to overcomplicate things too much. In the last video I mentioned that the foliage was an expensive effect and that I would optimize it further, and that's what I did. The game now runs between 8 and 15 frames per second faster, with far greater draw distances, and loading times have been sped up significantly, going down from about 34 seconds in this level to what is now just 7. I'll do a video about this later, but I'm mentioning this now because on Saturday, when I basically finished all the optimizations, I built the game, I loaded up the level, I walked around in the fields appreciating the improved performance, and I thought, wouldn't it be nice to showcase all of these fields while riding on a mount? So the idea of adding mounts came to my mind on Saturday in the afternoon, and in the evening I got to work on doing some preparation work for the feature, and at 11 PM I had done the first iteration of the running animation for the animal. That's basically how it began. The question you might have is, why did I choose this animal specifically? Well, going with a bouncy chicken is actually a very old idea, and I think I thought of it in like the 2nd or 3rd month of development. The reasoning is as follows. Animation is hard, I had no animation experience, so if I wanted to add a mount to the game, a horse was going to be pretty difficult. Even the Elder Scrolls Oblivion, which had a horse lady specialized for just this task, doesn't have the best horse riding animations. I knew for a fact that if I tried to add a horse, the poor quality of it would just make the rest of the game feel cheaper. The problem isn't even that it's a horse, but rather that the horse has 4 legs that all need to be coordinated naturally. On the other hand, an animal with only 2 legs would be substantially easier to animate. Another reason for going with the chicken is that my game utilizes a lot of squishing in many of its animations, and it also has an effect on gameplay, so I thought, why not make a mount who can be made excessively squishy without it looking weird? And lastly, this particular kind of animal plays an important role in the world building of the game, basically being the engine behind the public transport system. But I'll talk about that when I go over some of the quests in a future video. Anyway, the name of this beast is Lancelot, and let's now talk about how I brought him to life. Just like how I described in the video about the photo mode, video games are massive state machines, and getting the game into the state of being on top of a mount, that's difficult in and of itself. A mount is basically an entirely different implementation of the player's movement, physics, world interaction, animation management, etc. I was worried that this process would take a long time and that I would perhaps hit a brick wall at some point. I also predicted that implementing the moves like the run and the jump would be trivial in comparison, as I had already done it many times before for the many iterations of the main character's own moves. For the video about the combat, I actually did what is probably the most important work that I've done so far. Most notably, I wrote a new collision system that builds on what I learned on my first and second attempts. It sits right on top of Unity's physics layer, and its purpose is to take an entity and a velocity vector and to compute where the entity should end up when this velocity is applied. I used both conventional practices and also some borderline evil techniques to make the system robust on terrain that is often not at all modeled in a way that is compatible with most collision systems. For the same video, I had to make this collision system work for enemies who can be of any size, so I also had to make adjustments to the collision system so that it would adapt to entity scale and to generally just be compatible with entities who are far bigger than the player. With all of this work done months ago, I was able to just give the mount an instance of this collision component, give it some big colliders, and it just worked with no modifications. Except for some state management bug fixes which had to be done regardless. But a collision system is not the only thing, of course, because to make it do anything you need a velocity vector to feed into it. And how do you create this velocity vector? Well, that happens by letting the player provide input via the controller, and then that input is converted into a velocity vector somehow, but this is actually a very complicated process. It involves managing user input with input buffering, taking this input and doing a pretty complicated sequence of logical steps to decide which moves should be entered, giving these moves control over the animation system, allowing different moves to cancel into each other. There's the initiation of state transitions, such as that of opening menus, dying, warping, etc, etc, etc. And on top of all of that, there's also movement interpolation. Anything related to physics, which includes the player's collision system, is updated at a fixed interval, and interpolation is necessary to translate movement within this fixed interval into smooth motion at any frame rate. Basically, there's quite a lot that goes into creating a velocity vector, and wouldn't it perhaps be nice to reuse most, if not all, of that code? Could there be a way to take the player and just turn him into a chicken? The answer is yes, and it is yes because in the early stages of development I had made many decisions that weren't that important back then, but now they all came together to make it possible to turn the player into a chicken in just 2.5 days of work. So again, I started on Saturday, and when I logged off I had a chicken with a running animation, but there was no logic that would hint at it being a mount that the player could ride on. The next day at 2 PM I had the game in a state where the player was snapped onto the chicken's back, and I had given the chicken its own collision system instance and its own colliders. The next step was to give the animal its own custom moves, and this is where I got very lucky with the choice I made well over a year ago. Back then I wanted to do different characters with different moves, and for this purpose I wrote a modular move system. To get a different moveset, you would just take the slot of a move and put in a different implementation. You could swap in a new run implementation, a new attack, a new jump, whatever. And I had actually used this a few times during development, like when I implemented a new run and I wanted to quickly compare it to the previous implementation. But for the most part, this code was kinda just laying dormant. So, the mount would be the first real test of this modular move system. After doing a few fixes to the framework, I implemented very simple versions of the walk, run and idle moves, I slotted them in, and I checked if they worked, and to my surprise, it all just worked. Although moves have the freedom to transition to other moves when they want to, there's also a base layer of move selection that happens outside of this process, and this is independent of whatever moves are slotted in. For example, if you hold the control stick far enough, you will enter the move that's in the run slot, and if you suddenly release it, you enter the move that's in the sudden halt slot, and if you hold it a bit less, you enter the move that's in the walk slot, and if you hit the jump button, you enter the jump, etc, etc. Apparently I made the right decisions with this automatic move selection layer because I had to make no changes at all when I put in the chicken. All I had to do was implement the necessary moves, slot them in, and these automatic transitions worked out of the box. So after a bit of work, it was 5 PM on Sunday and I had the main character Edidin standing on top of the chicken, whose name is Lancelot, and the beast was moving forward with its own custom run implementation and its own colliders. At this point, the run was far from perfect, but still, riding the beast around was so much fun that I knew this was going to be one of the most important features in the game. So, let's now talk a bit about the chicken's moveset. As the purpose of a chicken is to traverse the ground really fast, it didn't make sense to make a complicated jump that rivals what the main character has. Because the main character has like 7 or 8 different jump types, the code that decides which jump is going to be executed and the code that decides how these jumps behave, it's all very complicated by nature. In the initiate jump function, for example, I have a pretty scary list of booleans where I strictly define the conditions under which a particular jump should be chosen. If one of these conditions is valid, none of the others are. Or in other words, the jump that you get is fully deterministic. And if there ever comes a point where the jump behaves differently from how it should, I just need to take like 5 minutes to step through these booleans with the debugger and the problem will be solved. This is critical as the jump is really the essence of a 3D platformer and I cannot afford to have this feature behave unexpectedly. But that's all for the main character. The chicken is about running really fast and that should come at the cost of something else. So not only does the chicken's jump implementation not really matter, it shouldn't even try to compete with the utility of the player's jump. So basically, neither the jump nor the freefall move were complicated. What is complicated though is the run itself, as that is really the whole point of this creature. So with that in mind, how should the chicken's run feel? What I wanted to avoid is to have the animal just be a method to go from point A to point B fast without the process of riding the animal being fun on its own. An example of what I mean is the mount in Visions of Mana, where all it really does is make the world feel really small. Even if you go as fast as you can, it feels like you're just a giant in a world that's shrunk down. Instead, a mount is supposed to give you the feeling that you're going so fast on an uncontrolled beast that it takes some effort not to crash into the trees. And it really should feel like you're just drifting through all the turns. A few good examples are Kingdom Come Deliverance's horse and the horses in Breath of the Wild, and I also quite like Torrent from Elden Ring even though he doesn't have too much weight to him. Generally speaking, the animal is supposed to feel fast and heavy, so how can we achieve that? To feel heavy, maybe we can do slow acceleration but with a high speed cap. Since we're going really fast, we probably shouldn't be able to turn very sharply, so let's reduce that a little bit. If you do turn while going really fast, you should of course lean into the turn or else you're just getting launched off. The interesting thing about leaning is that I implemented it a few weeks ago for the main character's new run implementation. The leaning behavior is part of the animation layer that the player uses, which I could very easily and quickly adapt to be compatible with any entity in the game and not just the player. So we've got the weight, we've got the leaning, and there are a few more tricks such as slightly bending the velocity into the direction you're pushing, but really the run wasn't that complicated after all. Most importantly, I think the controls for the beast now feel excellent. Something else to mention is that because I'm reusing almost all of the player's code unmodified, things such as bouncing on sheep, managing footsteps on different terrain types, ground and wall squishes, and various other tricky features, they were all working out of the box without needing any modifications. Anyway, late at night I had implemented all of the chicken's moves, all the animations were done, the run felt great, and when testing it was hard to put the controller down. Then all of a sudden it was Monday, the 3rd day of implementing mounts, and all I had left to do was to create smooth animations for getting on and off the animal. These animations are actually mostly defined in C# code. Lancelot spawns in and out with the help of an existing component that can apply a set of generic animations to any object. And the player is a bit more tricky, but basically I can compute the start and end positions of the animation and then use a curve to define the motion in 3D space that the player needs to traverse. I then just mix that with a spinning animation that goes right into the sit pose and it's done. So that is basically how I brought Lancelot to life. It was about 2 to 3 days of work, depending on if you count Saturday and Monday as full days or not, and of course there are still some more features I need to implement. Things such as death and damage currently don't work as they should, but I will work on those when I'm doing the second phase of developing the combat system. The same thing applies to warps, which I will work on when doing the second phase of the quest system. But considering that I was able to take this complicated system that was designed only for a small humanoid entity, and that I could push an entire chicken through it without issues, I don't think those remaining features will present many challenges. I guess the moral of the story is that there is a lot of value in deeply understanding all the code you write, and that you should write it in such a way that you yourself can go back into parts of the code base that you haven't seen in months, and that you can still rapidly add new features to it. I'm not talking about clean code or design patterns or any of that bullshit, and I'm also not talking about the handmade philosophy which says that classes and methods are evil, but instead I'm really talking about writing code that is in alignment with how your brain works. Of course you can only figure out what this optimal coding style is when you do a lot of work by yourself, which few people are going to be doing in the age of AI, but when you do a solo project this is a choice that you can make if you want. Anyway, I also hope that this video highlighted the value of implementing systems from scratch, such as the collision, the camera, which I didn't mention today, but also various other custom layers that sit on top of what the engine provides. It really does pay off both in the short term and in the long term. And I know for a fact that if I had used Unity's built-in camera or its built-in character collision, this comfortable 2 to 3 day process would have been a week-long nightmare. So, thank you all for watching and subscribe to stay tuned for the next video in which I'll either cover a tool for simulating all progression throughout the entire game, or in which I'll cover how I'm rendering millions of 3D objects at 100 plus FPS at native 1440p. Bye for now. And also tell Lancelot that he looks very strong.